All right, good evening and welcome everyone to Mount Washington Observatory Science in the Mountains lecture series. My name is Brian Fitzgerald, and I'm the Director of Education here for Mount Washington Observatory. Welcome everyone for joining tonight's program. Extra exciting program with the impending solar eclipse, the total solar eclipse that will be taking place this very Monday. And to help us learn all about the science and forecast conditions associated with it are astronomer Shawn Laastch from the University of Maine and weather observer Francis Tarasiewicz from the Mount Washington Observatory. Well, thanks so much for joining tonight's program. If you're not already familiar with Mount Washington Observatory, we are a nonprofit, member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And we do that through operating our Summit Weather Station with around-the-clock weather observation and forecasting, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have questions for either of our speakers tonight and you're joining on Zoom, make sure that you use the Q&A button. You can find that right at the bottom of your Zoom screen in the middle of the toolbar there. You can add questions at any point. We'll make sure to save time at the end to get to as many questions as we can. If you're joining through Facebook on the live stream, welcome. Thanks so much for joining that way. We won't be able to get to your questions in real time during the program, but we'll try our best following the program to answer as many questions as possible as well. If you'd like to sign up for a future Science in the Mountains program on Zoom, make sure you register over at mountwashington.org to do so. Alrighty, well, I don't want to take up too much time tonight. Before we kick things off and send it over to our speakers, I am going to share a poll with everyone joining in the audience tonight on Zoom. So if you are on Zoom, you should be seeing a poll screen pop up right now with 3 questions. We're curious, where are you joining from? We want to know which region of the country or outside of the country are you joining from tonight? Because we know tonight's topic will certainly impact millions of people across our country and beyond. Curious to know where you're joining from. Also curious, are you hoping and planning to be in the path of totality to view the eclipse? Maybe you already live there, maybe you're hoping to travel there. Curious with a yes, no, or a maybe. And then finally, curious, have you seen a total solar eclipse before? And we've given you 3 options, yes, no, or I'm not sure. All valid responses there. So give you just a few more seconds here to get your responses in. It looks like quite a few of you have already participated. And we'll close the poll here in 3, 2, 1. All right, we'll go ahead and share those results with everyone on Zoom. Overwhelmingly, 92% of you are joining from the Northeastern United States. However, we do have representation from every other region here, though predominantly the Northeast. This is certainly a local crowd, and I'm sure you're all very curious, particularly with the weather conditions that you'll hear from Francis about later on. Coming up there, we also are curious about whether or not you will be in the path of the eclipse. Are you planning to be? 65% of you say yes, 27% saying no, and there's quite a few that are undecided. No worries, you still have time here. And then finally, have you seen a total solar eclipse before? This is pretty evenly split between yes, no, and then at least a few of you saying, well, I'm not sure about that. Because as we'll hear about, they don't necessarily happen in your region in your lifetime very frequently. So so this is a really special occurrence. Well, anyways, I'll go ahead and stop sharing those results. And without further ado, I would love to welcome our first speaker, Shawn, the director of the planetarium at the University of Maine, there, the Versant Power Astronomy Center. Shawn, thanks so much for joining us, and thanks for giving your time. I know this is a super incredibly busy time for you. We're really, really thankful for you to connect with us tonight, and I'll just hand it over. Go for it.
Great. Well, thank you so much for having me. Yeah, looking forward to sharing a little bit about this upcoming total solar eclipse. One of the most dramatic visual sort of things that happens in science and in space, in astronomy, and something you really won't want to miss. All right, so with that, I'm going to see if I can start doing a little bit of screen sharing here with you. And we'll try and do that, and hopefully You are seeing a lovely image there of
It looks
totality
good.
here.
Yeah, you're
Good,
good,
good.
Shawn. Thanks.
Great. Yeah, so, well, I'm hoping I can convince you that you do need to, if at all possible, travel to the path of totality to experience a total solar eclipse. On average, if you were to stay on one place on the Earth, you'd have to wait about 300 years between total solar eclipses to take place at that one location. And so it is a very special thing, and it is something that is really dramatic. It's almost hard to put into words. And we'll get into a little bit about that as we go along here. So, as mentioned, I'm the director of the Versant Power Astronomy Center and Jordan Planetarium up at the University of Maine in Orono. If any of you happen to be up in the Bangor-Orono area at any time, feel free to come and join us there. We do a variety of public programs. We do lots of school groups, private events, things like that. We're part of the University of Maine, and we also have a small observatory out back too. That's an astronomical observatory and do some research stuff, but also some public observing as well. So I always like to start off with a little bit of history. People have observed eclipses basically since the beginning of time, if you will, and many cultures were very frightened of them because this was a very dramatic event, something where they thought that the sun was going out or being devoured or something like that. So both the Chinese and the Koreans thought something was eating the sun. In the case of the Chinese, they thought there was this celestial dragon that was devouring it. In the case of the Koreans, they thought that this fire dog from the Black Country was coming and devouring it. And in both cases, they would make lots of noise, bang pots and pans together, fire off fireworks, and eventually that would drive the dragon away. And it always worked. The dragon always went away and the sun always returned to normal. The Chippewa Indians thought the sun was going out, so they shot flaming arrows at the sun to try to rekindle it. And the Navajo thought it was an omen and such that it was a sacred time between the sun and moon, and it shouldn't be observed. So they actually would stay inside of their dwellings. So lots of different cultures, of course, looked at this and had a variety of things. There was even an occasion in sort of medieval times where there was a huge battle between the Medes and the Lydians, and a total eclipse happened, and both sides laid down their arms and stopped fighting. Wouldn't that be great if that happened today, given some of the conflicts we currently have in our world? People did figure out how to predict these things over time as well. And they actually were, once we figured out how they worked, they became pretty predictable. One of the first astronomical observatories that was used to do so was Stonehenge. Basically, people would stand inside these three-sided gates or henges, if you will, inside the stone circle and look out through them, watching where the sun and moon would rise and set over time. And from that, they figured out, of course, the paths of these two objects, and that allowed them to figure out that eclipses should happen on a regular cycle. All right, the Babylonians, the Chinese, the Celts all figured out how to do this. And the Babylonians even had clay tablets that were and they became so good at it, their tablets were actually used up until the 50s to correct some of NASA's eclipse tables. They had a base 60 number system, which is why we have 360 degrees in a circle, things like that. So they really got exceptionally good at predicting these eclipses. But ancient people, again, initially feared them, but then they started to learn how to predict these events and look for them. And there's even been some cases where people have used eclipses to trick other people too. So it is one of those very special things. Well, basically during a total solar eclipse, you have a very special alignment, sometimes called a syzygy, which is an interesting word, but basically you have the sun, the moon, and the earth in a perfect alignment for a solar eclipse. All right. And what's happening is the moon, of course, is casting a shadow on planet Earth. Now, this can only happen at new moon, but we don't get eclipses every new moon, and that's because the moon's orbit is tilted with respect to the Earth's orbit, about 5 degrees or so. Twice a month, there's a crossing point. That's called a node. And if that node takes place at either full moon or new moon, then we'll have an eclipse. If it takes place at new moon, we have a solar eclipse. If it takes place at full moon, that's when we'll have a lunar eclipse. For eclipses, of course, the shadows are what's important here. You want to be inside this deepest, darkest portion to see a total eclipse. And that's called the umbral shadow, and you'll even sometimes hear eclipse chasers called umbrophiles because they want to chase that shadow and be in that umbral shadow, if you will. There's also the penumbral shadow, which is the lighter area, that area, if you're in there, you're going to experience a partial solar eclipse. So for instance, the entire United States during this eclipse here in 2024 will get at least a partial. As an example, same thing in 2017, the entire nation got a partial. We had a partial here in Maine at that time, but it was total out west and down south, for instance. So it really does depend on where you are. That shadow will cross several thousand miles on Earth, but it's only typically 100 to 150 miles wide. So again, you have to be at exactly the right place at exactly the right time to see totality. And total eclipses, the totality portion, the really dramatic portion, lasts anywhere from a few seconds up to about 7.5 minutes. The last one we had that was 7.5 minutes took place in 1991. You have to wait till 2132 before we get another one of those. So I don't think I'll be around for that one. But here's another look at this. Basically, the moon is moving, and that shadow is actually crossing the surface of the Earth about 2,000 miles an hour. You have to be in this deepest, darkest portion, that umbral shadow, to see a total solar eclipse. The other thing to note is that eclipse paths will always move from west to east over the surface of the Earth, and that's because of the direction that the moon is orbiting our planet. So they're not going to jump back and forth. Sometimes when you look at flattened out Earth maps, the paths look a little bit strange because you can get lunar and solar eclipses basically anywhere on Earth. And so it is a matter that those paths can change and be very different over time. And there's a particular cycle to it called the Saros cycle. It's an 18-year, 11 and 1/3 day cycle where those paths look very similar, again, because of the way the moon orbits the Earth over time. So there's basically three types of solar eclipses. There are partial eclipses where only a portion of the moon is covering the sun. You have an annular eclipse, which is basically a special type of partial. So not only is the moon's orbit tilted with respect to the Earth, but it also orbits in an ellipse, meaning sometimes it's farther and sometimes it's closer. Some of you may have heard a term supermoon that the media likes to use. I'm not a fan of that, I must say, because you don't hear them use the word mini moon. Well, we don't really have either thing in my mind, a supermoon or a mini moon, but what we do have is something called a perigeel moon when the moon is at its closest point to us, and an apogeel moon when it's its farthest point away. And that happens once a month as well. If it so happens that the moon is at its farthest point away, its apogee point, and that's taking place at that node, um, then you have that alignment and you will get an annular eclipse. And this basically, you have a ring of sunlight left over. It's sometimes called a ring of fire eclipse, but it is a special partial, all right, because you don't get to see the corona, the atmosphere of the sun. But the most dramatic, of course, are the total solar eclipses. There's really nothing that compares to these. So that's the thing that, of course, we're really excited about because, again, this year we're going to have a total solar eclipse crossing the entire, continental United States. This gives you a little bit of a time lapse of what you would see. So you would see basically the moon starting to cover up a little bit of the sun. That's called first contact. It continues to do so all the way until totality, which is second contact. Just before that, you'll get something called the diamond ring effect and Bailey's beads, which are just little bits of sunlight that are shining through the craters and mountains and valleys on the moon, which are really dramatic. Then you'll have totality, and that's when, of course, you're going to see the atmosphere, or what's called the corona. It's the only time we're able to do so is during a total solar eclipse. It's this very thin, tenuous area. It's 1/10,000th as bright as the surface of the sun. And again, so the only time we can see it is during totality. And then the moon will slowly move off the surface of the sun and reveal the sun to us once again. This entire process takes a little over 2 hours of time. Typically, you have roughly an hour and 5 to an hour and 10 minutes before totality, and then about another hour and 5 to 10 minutes after totality. And then the totality portion itself, like we mentioned, a few seconds, all the way up to about 7.5 minutes when you'll get to see that glorious corona. Now, this is an image of a total solar eclipse that myself and one of my graduate students, Nikita Sani, took last April 20th of 2023. We're on a NASA citizen science project called CATE 2024, which stands for Continental American Telescopic Eclipse. That's a mouthful, hence the acronym. Basically, we're going to be setting up 35 stations between Texas and Maine to record polarity data on the corona. All right, and we actually were the Northeast Regional trainers. Well, they sent all the trainers down to Australia because we were testing 3 different camera rigs to figure out which one we were going to be using for the project this year. And this is an image we took. You see the corona here, which is really dramatic. You also see some prominences and flares off the edge of the sun. And this particular eclipse and also the one this year should be really dramatic in that way because we're near a solar maximum. So it should be, we should really have a dramatic corona for this. This eclipse only lasted 62 seconds, the totality portion that is, and it was 4 days of travel each way to get to and from the area in Australia we were observing. So a long way to go, but it was really spectacular. And one of the things about eclipses, it's not just this corona and looking like there's a black hole in the sky, but the sky darkens. It doesn't get completely like night. It's more twilighty all around the horizon. You will see brighter stars and planets. The temperature drops a few degrees. The winds will die down. Birds and animals pay attention. It really is something that you not only see, but you feel. And it's a complete different experience if you're at 99.5% or 99.9% to 100%. So I tell folks, you really want to get to the path of totality. The difference between the two in my mind is like seeing a lightning bug or getting hit by lightning, or flying in a plane versus jumping out without a parachute, or for you who have kids, taking your kids 99% of the way to Disneyland, or taking them inside and letting them experience the rides and the characters. I think they'd be a little bit happier with one versus the other. All right, so this gives you an idea. Totality is really, really special. And the first time you experience it, you'll understand why ancient people feared these things. And you also probably will want to see one again because they are that dramatic, and many people will chase them around the world once they've seen their first one. I've been lucky. I've had a chance to see 5 total solar eclipses over my career. Each one of them is spectacular, dramatic, and unique. And I really am looking forward to this one coming up here and hoping it'll be number 6 coming up April 8th. Well, as I mentioned, the sky doesn't get completely dark. This is an image from out west, basically during the eclipse in 2017, and this is before totality, and this is during totality. Now, the picture does it somewhat justice, but not completely, because again, it will be bright enough to see some of those stars and planets, but again, it is not completely dark. It's not completely night, I should say. Now, if it was totality and you're in the path of totality and we have cloudy weather, then it would get completely dark. Dark as night. All right. But normally you have this twilight effect. The sky is really silvery just before when you're at like 99.5%. The shadows get weird. You might experience shadow bands, which is sort of atmospheric effects on that you can see on the ground. It really is a dramatic thing to see. So I hope you have a chance to do so. Well, this is the path of totality. It's going to start off in the Pacific Ocean, cross into Mexico, Texas, on up through the central United States, into the Northeast, Canada, and then it will finish just before it hits the coast of Ireland. All right. Now, I used to be telling folks, and we'll be getting into this more with weather later on, but I used to tell folks that for this eclipse, the best place to be would be Texas or Mexico. And it's not because things are bigger in Texas. It just so happens that the moon is a little bit closer. So Texas and Mexico get about 4 minutes and 28 seconds of totality. Here in Maine, we're going to get about 3 minutes and 28 seconds, again, because that moon's orbit is changing as it moves. And so it's a little bit different in those places. And initially, Texas had the best weather predictions, at least historically. But we'll learn a little bit later what's going to happen with weather and whether we're good or whether Texas might be better. We'll have to wait and see on that point. Well, these are the paths basically for sort of the Northeast region. So I sort of included Maine, New Hampshire, and Vermont in terms of the path. You can see that the path doesn't cover these entire states. In fact, here in Maine, where I'm at, the most populous regions don't get totality. So Bangor, Orono, which is where I live, Augusta, Portland, none of them get totality. You have to be farther north. Our team is going to be in Jackman, Maine, right on the center line, right about here to give you an idea. And of course, in New Hampshire, it crosses through just a very tiny sliver of the state. It's also not going through, Concord or Manchester or some of the more populous areas. Now, the good news with Vermont is they do get it in Burlington, so they are getting it through at least one of their more populous areas. But again, it really depends on where you are. If you're near the edge of that path, you won't get the full, you'll get totality, but you won't get it for the length of time. So for instance, I tell folks like in Maine, if they can get up to Lincoln or Milo or Dover Foxcroft, they'll get totality, probably 40 seconds to a minute. But again, in Jackman along the center line, that's where you're going to get about 3 minutes and 28 seconds. And the same in, you know, these areas here on the center line, then you're going to get the full thing. If you're near the edge of that, you'll get a little bit less. You may only get a few seconds or a minute or two of totality. But this gives you an idea, and you can go these maps are from the Great American Eclipse. You can look up greatamericaneclipse.com and they have maps. They'll have timings because it's really important to know when the timings for your eclipse are as well. The key thing with any eclipse, of course, is watching these things safely. Now, the sun is no more powerful on a day of an eclipse than any other day of the year, but people want to see what's going on and they tend to stare at it. But the problem is your retina doesn't have pain receptors, so you can burn your retina, doing potentially permanent damage. So please don't do that. View this thing safely. Solar eclipse glasses block out 99.9% of the incoming light. They are designed for viewing the sun. They're not like sunglasses. Sunglasses protect you from glare, but won't protect you from the sun. You should never stare at the sun any day because it can do damage. But people want to during an eclipse. That's why you need these eclipse glasses so that you can view it safely. We happen to be a source here in Maine, but there's plenty of places you can get them. They should be about $2 a pair, so don't let people scalp you for them because they should be very reasonable. $2 or $3 a pair is pretty reasonable. Some libraries even got some from NASA to give out free, which is wonderful as well. Another way you can do this is to use pinhole projection. That's where you have your back towards the sun. You let the sunlight shine through a pinhole and project onto another surface. You can do this in a box like is being demonstrated here, but you also can just take an index card, poke your name and the date, stand with your back towards the sun and let the sunlight shine through and it will project it on the ground. Leaves, if you're underneath a tree that has leaves, it will often project through those, pinholes there. I've seen people use a colander too. Basically anything that has a little hole in it will project, allow you to see a projected image. Again, you're not looking through those holes, you're looking at the projected image, which is safe to do. If you're using a telescope, you do need a full filter that fits over the objective or the front portion of the telescope. Never use the eyepiece ones because those can crack. And I do tell folks it's better to use glass if at all possible. Glass is much safer than Mylar. It's stronger. You don't have the chances of getting scratches or pinholes like you do with the Mylar ones. They're usually about maybe 20% more than the Mylar ones. They're well worth the investment because remember, if you're looking at it magnified, that can do serious damage to your eyes, much more even than just looking with your unaided eye, because it's like, think of an ant underneath a, magnifying glass. It's not good. Also, don't use your solar filter glasses to look through a telescope. That is not safe either. So folks have asked about welder's glass. You can use welder's glass, but it needs to be number 14 or higher. Anything less is not safe. So again, just be careful with your eyes. You need your eyes for more than seeing eclipses. So do take care and view this thing properly. You'll need it for all the partial phases during totality again. Then you will want your glasses off or your filter off because the corona, if you have those filters on, you won't see it because the corona again is 1/10,000th as bright. That's an ethereal atmosphere of the sun. It's about 2 million degrees, which is really interesting because the surface of the sun itself is only about 10,000 degrees. And it's one of the areas we're still trying to really understand about the sun. It's the start of the solar wind, and a variety of our space weather travels along that solar wind to us, so it is an area of the sun that we're trying to understand. Our website, astro.umaine.edu/eclipse, or just even astro.umaine.edu, has a whole variety of eclipse resources there, links to where you can find timings, a whole variety of safety information and tips, things of that nature. So do feel free to check that out if you like. It can help you in making some plans for viewing the eclipse. Also, if you plan on traveling someplace, note that getting there probably will not be too bad, but you should get there early. Coming back typically will take a lot more time because everyone will try to disperse. So if you can stay longer, maybe have some dinner, relax, whatever, that's better. But just be aware that if you leave as soon as the eclipse is over, everyone will be trying to do that, and it probably will take you quite some time to get back home. Now, I mentioned that, of course, these things are somewhat rare. Again, we do get solar eclipses every 12 to 18 months, but you have to be on the right place on Earth at the right time. So, again, we had one in 2017. Now this one is, April 8th of 2024. But you'll notice that there are several others that are going to be happening in 2045. There will be one that crosses the entire continental United States again. There's one, in August. It's going to pass up through Canada and just a portion of the northern states. And May 1st of 2079, the New England region again will get totality. In that case, it's going to go sort of right up the coastline. So it'll actually be in a very populous area of the states to see that. So we'll have to wait and see, but that'll be in 2079. There are, as I mentioned, these happen often. There's also annular eclipses. The red paths you see here are annulars. And the one that we actually went to last year was a hybrid. It started off as annular, then became total, and then back to an annular over time. We were right there. That little spot in Ingaloo just barely touched the tip of Australia, which is where we were. If you missed this one, the next opportunity to see a totality is August 12th of 2026 through Greenland, Iceland, and down into Spain, to give you an idea. But you can find these maps. They're on NASA's page. Also, you can find the great canons of eclipses that let you know when all these different eclipses take place. And with that, that's my contact information. You can find me at, again, astro.umaine.edu or at Facebook, Jordan Planetarium. And my email, the easy email for me is just planetarium@maine.edu as well. And always look forward to chatting with folks about the eclipse. Alrighty, with that, I'm going to stop sharing here and turn things over to Francis, who's going to tell us about the weather, which is the really important part.
Yes, well, thank you very much for that, Shawn. That was amazing. I learned quite a bit myself, so it's always cool to learn something new every day. So yes, as Shawn said, my name is Francis Tarasiewicz. I'm one of the meteorologists up here on the summit of Mount Washington. And before we talk about the eclipse forecast, I just briefly want to discuss what occurred on the summit today. As I'm sure most of the audience knows, New England has been experiencing a really strong system today with snow, strong winds, even some icing as well. But up here on the summit, it was a fairly typical storm. We had a max wind gust of around 123 miles per hour. You can see that there. That occurred around the noon hour or so. And winds right now have died down a little bit, still around tropical storm force at 55 miles per hour. Here's a view of winds through the day. They increased very steadily, and they peaked right after noon there. Again, 123 miles per hour. That's a Category 3 hurricane. And I briefly wanted to take you all out to the deck cam to see how much snow has fallen. And yeah, you can't see too much. There's been a lot of icing as well, and an easterly wind to boot. So a lot of that ice has blown up onto our camera. If you're looking for our webcam, mountwashington.org. And so I want to preface a few things before I begin this forecast. And my first preface would be to say that forecasting cloud cover is extremely difficult. And so this forecast is, of course, subject to change. I would recommend, of course, getting to know your local National Weather Service office site. You can go to weather.gov and you get up to the day forecasts as we get closer and closer to the eclipse. And so the way I'm going to break things down with the forecast tonight is I'm first going to start from a very wide perspective. I'm going to start in the upper part of the troposphere where we live down here in the lower part of the atmosphere. I'm going to talk about what the jet stream is doing, because that is the easiest part of the forecast. And then I'm going to turn things over to the more difficult part of the forecast, and I'm going to try to identify areas of cloud cover and storminess that will occur or may very well occur on Monday 8th. And so without further ado, I want to get started here looking at a map that may be a little bit confusing at first, but what we're looking at here are 250 millibar winds. These are jet stream winds at the level where planes fly. And this is the forecast for right around eclipse time on Monday. And so these darker colors indicate stronger winds of the jet stream. The lighter colors are, again, of course, lighter winds. And so the reason I pulled this up is because this gives us a sense as to what the overall atmospheric pattern may look like on eclipse day. It's much easier, it turns out, to forecast these upper level winds than it is to forecast actual cloud cover. And so I'll put my meteorologist hat on a little bit here. And so I want to identify areas of interest with the jet stream, things that catch my eye immediately with the forecast. What you'll notice here is a little bit of a bend in the jet stream. You can see my pen there. This is a area of low pressure up above around, again, 20,000 to 30,000 feet or so. This will be located over the desert southwest. And so Scott had talked about typically the southwest tends to be the sunnier spot. There are indications at the moment that this may not be the case for the eclipse, that in fact the southeast, or the southwest, I should say, may be one of the more cloudy spots, Texas in particular, and portions of the mid-south there. Going further north, the jet stream is kind of coming together. Let me grab my pen there again. And so going further north, you'll notice the jet stream is kind of coming together. That's called convergence. That means that air is sinking overall, in general, and so that means higher pressure, the potential for clearer skies. Again, a lot of cloud physics and processes like that are the hardest thing to forecast in meteorology at the moment. So again, we'll see some convergence over portions of the Ohio River Valley. Now, at the moment, the best spot for eclipse viewing is ironically New England, and you'll see why that's ironic going forward in a little bit. You see this little curvature again in the jet stream here. It's curved what we call anticyclonically. So that means there is a ridge of high pressure upstairs, and that may extend all the way down to the surface if we're lucky here in New England. So that bodes well, at least at the moment, for our weather forecasts. So I talked a little bit about the jet stream. We're going to now talk about what's going on potentially near the surface of the Earth for eclipse day here. And so the folks at the Aviation Weather Center, they work really hard to make these future forecasts for aviation interests. But here we can use a much easier map maybe than what we saw with the jet stream map. We can identify areas of high and low pressure. And just as a brief review for any of you who may not know, of course, areas of low pressure, you think low pressure, worse weather, right? Rain, snow, sleet, hail, things like that. And high pressure is quite the opposite. You've got better weather there. So this is the current forecast for the entirety of the United States. You can see here across the south, Aviation Weather Center's highlighting a general area of lower pressure across the southwest, areas like Texas. It's also showing what's called a stationary frontal boundary. Now, stationary frontal boundaries tend to focus cloud cover and precipitation. So unfortunately, we'll have to see how that pans out, but at the moment, it's not looking too great in terms of cloud coverage for areas, especially across eastern Texas and into areas of the mid-south there. Going further north, you can see a couple more red L's. This will be an area of low pressure, pretty broad one that'll stretch from portions of Iowa down through Missouri and areas of Illinois. The good news about this system is that it's going to be on a weakening trend. So the amount of cloud cover and precipitation associated with it will be decreasing throughout the day on Monday. The Aviation Weather Center also highlighted a broad area of potential precipitation that may stretch from the parts of the Ohio Valley all the way up into the southeast as well as the upper plains. And so there could be some scattered showers, at least at the moment. That's what the indications show for areas, say in Ohio. But there are indications that the showers will be on a decreasing trend. It really depends on how quickly this low center starts to weaken and push its fronts away from the area. My last stop here along the tour will be New England here. This is what we like to see, at least in New England, a very large area of high pressure. So that means that winds are going to be going clockwise. So we'll have a nice dry northerly wind for most of the area. Again, higher pressure meaning better weather. So a better chance, at least at the moment, there could be some changes in the forecast for more ideal eclipse viewing conditions for portions of New England. I want to take a look now and look at the cloud cover forecast going through eclipse day. So I'm going to start here Sunday. This is Sunday afternoon. Remember that storm system I mentioned, the big area of swirl here across the central United States. You see that front across Texas, and you'll have a low pressure generally in this area with another front ahead of it there. So moving forward, we'll move into the latter part of Sunday. That system, you can see it swirling away. Again, this is forecasted cloud cover. Sunday night, getting into Monday, getting closer to eclipse time. When we finally work our way into Monday morning, you can see that this particular model shows quite a bit of cloud cover again across portions of eastern Texas that extends another band of clouds up through the Ohio Valley and portions of the Midwest as well. And then we'll go a little bit closer to eclipse time. And you can see, unfortunately, clouds increasing over areas of southeast Texas, clouds potentially decreasing over the Ohio Valley, and some high-level clouds across areas of, say, New York State. But again, northern New England may very well luck out on this. And again, in just a little bit, we'll talk about why that's just so, it's such an interesting turn of events for folks up here in New England. I want to zoom in a little bit closer now to different regions. So we've got Texas here, and lots of the Mid-South. This is, again, the cloud cover forecast, zoomed in a little bit on a region. So we'll start here in Texas. We'll advance that clock now going towards eclipse time. We can see, again, lots of low-level clouds being forecasted at least across portions of east central Texas, and then portions of the upper Midwest as well. And right around eclipse time, those clouds may stick around for quite a while. And that upper level low to the west in the jet stream may provide quite a bit of cloud cover, unfortunately, for portions of the Mid-South. Things, of course, could change point to point, and so we'll have to keep a very close eye on that going forward. Moving up to the center of the country, looking more towards the Ohio Valley, we see, of course, a lot of cloud cover to start the day as that front is going to be moving. But again, I said that storm will be on a weakening trend, so that front will be weakening as well. And so moving the clock forward, you'll notice that the clouds tend to clear up portions of Illinois, Indiana as well. Right around eclipse time, that clearing even pushes into areas of Ohio, Kentucky, Tennessee, and across portions of the southeast as well. So potentially some good news there for folks who may start the day on a cloudy note. They may see some clearing by the afternoon. Our last stop for our cloud cover tour will be northern New England. So again, this is starting early Monday morning. So we see a lot of blue here indicating the chance for more in the way of clear skies, clear conditions. But I want to point your attention now to this area of higher clouds across portions of New York State and Pennsylvania. And this could play a factor as we go throughout the day. Again, that frontal system is moving from west to east throughout the day. And so we'll see some of those clouds tend to stream in as we get into Monday. This is around noontime or so, and then even more clouds potentially across areas of New York State, Pennsylvania as well. But mainly clear skies, at least forecasted at this point for portions of northern New England, where really the longest totality in New England may occur. It's Burlington there. This current model is only showing about an 8% sky cover, which would be phenomenal for the eclipse viewers there, getting their full 3.5 minutes or so. But that clear extends into portions of northern Maine and New Hampshire as well. So we're really crossing our fingers up here on the summit for a clear view. We'll be just outside of totality, and so I'll be wearing my eclipse glasses to safely view the eclipse for the entire event. So we'll never quite reach a totality, but hopefully we get some great pictures from up here on the summit. I want to take more of a zoomed-in perspective, city by city, hopefully, of an eclipse forecast to the best of my ability at the moment with the data that we have. Of course, things I will remind you all can and certainly will change as we get closer and closer to Monday. But I first want to familiarize everyone with a couple of terms here, but maximize that. I want to first talk about weather versus climate. So climate is what we may expect on a given part of the year, and weather, of course, is what you get on each given day. So weather describes short-term atmospheric conditions, and the climate is a long-term average over a longer period of time, generally 30 years or more. So these are a couple of terms to keep in mind. I've got a couple more in terms that I'll be discussing throughout the PowerPoint here. The word ensembles. It's not a group of musicians. In this case, at least, we're talking about a group of computer models that are each run with slightly different beginning conditions. So each of them shows a slightly different result. Ensembles help us to see the spread in a forecast, help us to communicate the uncertainty, of course. And that helps us as forecasters to give you your rainfall chances or your snowfall chances, right? And then the last word I want to talk about is member. That's an individual model from an ensemble. And I hope that makes sense to everyone. But of course, questions are definitely welcome, at least at the end of the presentation. This is a map of the United States. We also have totality marked here in red, the path of totality. Again, as Shawn said, that's going to be moving from generally west to east, or by southwest to sort of northeast. But it's going to be quick, right? The path of totality. And so this is the climatology of cloud cover for the entirety of the United States. And on average, as we were discussing earlier, these areas of brownish shades, these yellow shades, this area tends to see a lot more in the way of sunlight between April 1st and 15th, around the time of totality. As you go further northeast, on average, the climate suggests that it tends to be a little bit cloudier, right? In New England, we're very familiar with the term April showers brings May flowers, and that's really reflected here. On average, cloud cover, you have about a 60 to 70% chance of seeing some sort of cloud cover, and your skies may be maybe covered as much as 60 or 70% as well. And so we're kind of flipping the script with this forecast, which is definitely great news for people in northern New England. I want to give an example now of cloud cover percentage chances from the summit of Mount Washington. I crunched the numbers a few weeks ago. And between the years 1935 and 2023, 81 out of 88 years experienced some sort of cloudiness or fogginess. That's 92%. So again, we're really hopeful up here that our chances our luck wins out for this particular eclipse. And that fog on average lasted 16 hours each day. And so on the summit up here on Mount Washington, we spent about 60% of our year in the fog. So it would be a really, really special treat for us to actually be in the clear. And so this is a typical view from the summit. You might be able to see this bank of clouds and fog. Typically hangs out right at summit level. So again, we're really crossing our fingers here on the summit for a clear day. I want to now talk about the chances for cloud cover as we move from the southwest United States all the way up into portions of Maine. So we're going to take a city by city look here. And again, this is based off of the latest model data. This can and certainly will change as we move forward. So we'll start with the city of Austin, Texas, of course, in the path of totality. And right now, unfortunately, the amount of models that suggest cloud cover are around 76% here. And so I talked about the members here. We see about 26% of members here on your screen showing favorable conditions for cloud or for eclipse viewing, which isn't great. 44%.
Francis, I'm sorry to interrupt, but could you share your screen fully?
Sure. I just won't be able to show
just to read it a little more clearly. Appreciate that.
Of course, yeah. Yeah, definitely.
Oh, so, perfect. Thanks.
Great. I hope this helps everyone's vision there. So yeah, the 26% of members are showing a more favorable sky condition for eclipse viewing. 44% of members are showing a somewhat favorable sky. So maybe partly cloudy skies, mostly cloudy skies. And then about 30% of those are showing more of an unfavorable sky with more in the way of overcast skies as well. So that's Austin. We're going to zip up the United States. We're going to go all the way to Little Rock. Your chances are a little bit better up here in Little Rock. We've got about a 52% chance for cloud cover. And so 74% of the model members are showing, again, a more favorable outlook for eclipse viewing conditions. That'd be greater than 75% of the sky being clear. 14% are somewhat favorable, and then 12 are very much unfavorable. So decent chances here, and there may be a partly to mostly cloudy sky in the area of Little Rock. Again, as I mentioned, that frontal system is going to be pushing way to your west if you do live in Little Rock. Carbondale, Illinois. It's going to be right behind that front. The area is going to be sinking down and drying as it does so. And so the models show only about a 23% cloud coverage on average. And so that means 85% or so of the model members are showing favorable eclipse conditions. So Southern Illinois might be a pretty decent spot for eclipse viewing, at least totality viewing, with only 7% of the members showing unfavorable conditions for the eclipse. Coming up now to Cleveland, Ohio. Again, it's going to be that area where that front's moving through, where clouds are beginning to break up, perhaps during the afternoon hours, maybe right around the time of the eclipse. But again, it all depends on the timing of that front. And so right now we see about a 50-50 split. We've got 50% showing generally favorable conditions for the eclipse viewing with, again, greater than 75% clear skies. And then somewhat favorable, we fall down to about 34%. And the unfavorable, the least frequent, that's about 16%. So leaning more towards a favorable to somewhat favorable viewing conditions up there in Cleveland, Ohio, and really through a large part of Ohio. But I would say with the state of Ohio, you'll have better chances viewing the eclipse further southwest, at least at the moment. And again, pay attention to your local National Weather Service office. Niagara Falls, I'm sure this will be quite a popular spot for folks. 62% of members showing favorable conditions. So we're leaning towards more of a favorable view here. The average cloud cover from the models, maybe around 60%, so maybe a partly to mostly cloudy sky that particular day. 22% of the members show somewhat favorable conditions for the eclipse. And then finally, just 16% show outright unfavorable conditions. So the issue with New York State is, again, you might have some of those high clouds filtering in throughout the day, and especially thickening towards the afternoon, maybe right around eclipse time. So we'll have to keep a close eye on that as we get closer to Monday if you're traveling to portions of New York State. This is where it gets much better. Burlington, Vermont, 18% cloud cover on average from the models. A full 91% of members agree that the sky conditions may be actually quite good for totality viewing, and only 2% of those members suggest poor conditions for totality viewing. So really, as you get further north and east, ironically, with this particular event, your viewing conditions do get a little bit better. Finally, Caribou Moon. I told you it would be fast. 95% of members showing favorable conditions, 5% of the members showing somewhat, and then actually no members suggesting any kind of unfavorable conditions for viewing the eclipse. So really, northern New England may very well be the best spot to view this eclipse. And so I want to wrap up. I've gone over a lot of information there, but I want to wrap up talking about some weather headlines from the day of the eclipse. And again, of course, as I've been saying, these are indeed subject to change. And I don't like to repeat myself so much, but just want to definitely make you all aware that weather can and will change. We would especially know that on the summit of Mount Washington. So here's some headlines. Again, across the southwest, the stationary front and favorable upper level winds may produce cloudy skies across Texas and portions of the southwest, which really is the opposite of what we typically see with climatology. Again, this is again subject to some minor changes. The central United States will move on. We'll see a broad to weakening area of low pressure over Iowa that may spread areas of showers and cloud covers over portions of the Ohio Valley, but those will be in the process of moving to the east throughout the day. And then New England, we'll see high pressure building in across eastern New York, but high clouds from that front over the Ohio Valley may limit visibility for areas a little bit further west. However, the best chance of pristine conditions will be over New England. And so with that, I want to turn things back over to Brian, and we'll take any and all questions related to the eclipse. Thank you all.
Awesome. Thank you so much, Francis. Thank you, Shawn. Shawn, welcome you to rejoin the program too. Let's see if I can set everybody up for a nice gallery view so everyone can see our smiling faces, because we're all so excited, clearly. Hope all of you who have joined tonight are really looking forward to this event coming up here Monday. And for those of you in the Northeast, all the more reason potentially to be smiling, especially given the information from Francis here. So yeah, without further ado, there are already a bunch of questions that folks have been adding to the Q&A button on Zoom. So please feel free right now, and as we're speaking here, to get those questions in. We'll get to as many as we can here. And certainly, if you can't reach out following the program, you can always reach us at education@mountwashington.org, as Francis has up on the view board there. So let's see, where shall we begin? Maybe from a historical perspective, this is the very first question from Steve and Shawn. I'm not sure, testing your history of New England eclipses a little bit, but do you happen to know when the last total or annular eclipse was that came across the New England area?
So Maine had a totality in 1963 was the last time, and prior to that there was one in 32 that crossed through Maine as well. I do know there was one I want to say it was around 1970 that was sort of a little in the Virginia area, but those would probably be the two recent ones, you might say, in terms of the New England area.
Yeah, I think for Mount Washington in particular, we did some digging with the help of our curator, Peter Crane here, who pulled up some of the local papers of the day. 1932, right before the observatory actually was founded later that year, I guess was the last time Mount Washington was in the path. And it sounded like it was a great fanfare, lots of people coming to the summit. Though, per Francis's climate statistics there, yeah, it was a cloudy showing that day, I think, for folks. And so it'll be a while still, I guess, until Mount Washington's back in that spot again. But thank you. Thanks, Shawn. I appreciate that. Some other questions here. A lot of great questions related to viewing in particular. I know there are certainly a variety of ways, and Shawn, you already mentioned a few, but a question here from Kevin was asking about, can I use binoculars during totality? Is that a safe and maybe even an interesting way to view the event?
Yes, but you must take great care to know the timings, because even just the tiniest bit of sunlight, like the diamond ring effect or Bailey's beads, would, is a serious amount of light that could damage your eyes. So what I tell folks, if you're using binoculars, you want to know the timings very exact. I would wait till maybe 4 or 5 seconds after totality starts to use them, and then I would make sure I would stop using binoculars 4 or 5 seconds before totality ends. Again, you want to be careful with your eyes, because you will get a nice view of the sun that way, but just be aware that if you get any light that's not total in there, you know, that then you're going to have, you know, issues and can do some serious damage to your eyes.
Message received. I hope also from our audience as well. Yeah, certainly that was one of the more interesting facts I've heard from you and from others around just how not so sensitive our eyes are, I guess, from that pain receptor standpoint when even just the partial phases of the eclipse. We know during a sunny day we can react right away, usually in a full sun sky. Oh, I don't want to look at that. That doesn't feel very good, but maybe not so much during those partial phases. So good to know. Similarly, there's a question that I know comes up quite a bit. This question from Lee was asking about any tips for photography with a cell phone. From what I know, you don't want to risk damaging that cell phone, and especially your eyes trying to point your phone up there. Any tips with cell phone photography?
They do make a few like filters that will fit over your cell phone. It typically covers the entire cell phone. And for the partial phases, you would want to use those again because you risk burning the sensor. That's true with any camera. If you're going to take images, you need a filter for the partial phases. Then at totality, you can, you know, take the filter off. One of the issues with photographing eclipses in general is you have to really, to get totality, you have to do a lot of bracketing. So unless you have a camera that you can sort of set and forget that will do that bracketing, you can spend a lot of time fiddling with your camera. I tell folks, particularly if it's your first one, don't try to photograph it or video it. There will be plenty of people who do and who are professionals. Take time to drink it in because it really is one of the most spectacular things you'll see. And if you're fighting your camera or whatever, you're wasting time that you could be seeing this thing, which is very short. Every eclipse, even though that, you know, we get 3 minutes and 28 seconds here, and if you could be at the best place, you get 4 minutes and 28 seconds for this one. Every eclipse feels like it's about 10 seconds long. You'll hear this 5, 4, 3, 2, 1 in your total, and it almost sounds like 5, 4, 3, 2, 1 and you're out. So yeah, so you know, drink it in.
Yeah, I guess, the length of, if it's 3 minutes, it's the length of a song on the radio.
Yeah,
That's quick. That's
exactly.
really quick. That's helpful. Francis, a couple questions here. Well, one from Chris, who was asking about recording of this video and sharing. I'll just add that, yes, for anyone who's looking to share this video with family members or friends, we are recording the program. We do share it on our Observatory Science of the Mountains page and also on the Observatory's YouTube page as well. So please feel free to check that out. Tomorrow it'll be posted up. And then Francis, from the Observatory side of things, someone's asking about whether we'll be live streaming. I know we will be live streaming at minimum. The backup plan for a lot of places is NASA is live streaming a great capturing the full span across the country, especially if there are cloudy conditions. But what are some good ways from the observatory side of things that folks might be able to view our cameras or things nearby?
Sure thing. So you can go to our deck camera, which is at mountwashington.org. You can also go to the tower camera. That will be more westerly facing, but I suppose we could adjust it to look more closer to the sun. But of course, we'll be just outside of totality. So you may not see too much of a difference. We'll be right on the edge, 99.97% or so. So it'll still generally look like a bright sunny day. I do know one of the observers is planning on potentially taking more of a time-lapse sort of view of the eclipse as it goes by. So that'll certainly be released on our social media following the event. Yeah, certainly mountwashington.org is a great place for our webcams as well. And I do know some observers, our former observers, are participating in the Citizen Science Project Kate up in northern New Hampshire to actually sort of document the corona as it passes through the northern part of New England. Yeah, good question.
Excellent. And Shawn, are you aware of other live streams taking place elsewhere?
I do know that the University of Maine, we have there's a high altitude balloon group with us that's going to be launching a balloon and streaming from the balloon. So that is planned as well for the for things here, and that if you go to our Eclipse page, there'll be links there to find that live stream.
Excellent. Well, here's a great question from JB, who's asking, Francis, I know we cover this a lot in making sure people are clear on this one, but I know you mentioned weather, you mentioned climate. What are those primary differences between those two again, just so folks are clear and sort of those time frames we're typically talking about with the two?
Definitely, yeah. So you can think of weather as sort of your daily state of the atmosphere. It's a cloudy day, right? Today was colder than average on Mount Washington. Whereas climate is more of your long-term averaging of weather conditions, typically 30 years or greater. And so we can take the climatology of a lot of different things. We can look at the climatology of precipitation or what's falling from the sky. We can also look at the climatology now of cloud cover. So I did show that map a few slides ago. And so yeah, I hope that sort of helps to clarify your question.
Yeah, definitely. I mean, so that minimum time frame, usually that 30-year period at minimum again, in which we're talking about climate to average out that much weather data before we consider it, I guess, normal or typical sort of conditions, right? Well, I have a question here from Casimir for you, Shawn. Perhaps, any suggestions just more generally of what type of general environment, say you're in the path of totality? I mean, what's a good place that you might recommend folks go and set up camp? I mean, would it be a field on a mountain, a lake, a parking lot? I mean, any general suggestions?
Yeah, I mean, basically you want a good view of the west, west northwestern sky. This event here in New England, it's going to be somewhere around 30, like in Maine, it's going to be about 35 degrees above the horizon as you get, a little bit towards New Hampshire and Vermont, probably, 37, 38 degrees. So, it's not going to be super high in the sky. So you want to make sure you don't have any big trees in the area or what have you. If you're up on a mountain, sometimes that's really cool because you can see sort of that shadow rushing in on you, which is quite eerie, and kind of dramatic as well. But really, you just need a good open area where you can see the sun. That's the key thing. And the other thing, we say here in Maine that we're in mud season right now too. Please don't just pull off on the side of the road because you might get stuck and then you might cause problems for other people and first responders and things like that. So, just be courteous. So if you need to get somewhere, try to get to a parking lot minimally, or a field or someplace that's, good, but versus just pulling off on the side of the road.
And similarly, Shawn, we were talking just before the program about at least my own day tripping plans and others, and some of those other pieces of, I guess, from a resource and time perspective, those other things you might want to keep in mind, like at least some snacks and some patience.
Yeah, be prepared is the motto that I grew up with, but it very much is important for this eclipse. Typically, you'll probably be able to get to your site if you leave in the morning, but then coming back, everyone will disperse as soon as the eclipse is over. And in some cases, that means you might be in your car for 5, 6, 7 hours or more. So depending on what kind of roads and things like that. So just be aware that it's good to have warm clothing, have a full tank of gas, have some snacks. If you have kids, have some entertainment options for them because there's the chance of being in the car for a while.
Good.
If I may add one more
Yeah.
thing specific to this upcoming weekend and then Monday. So of course in New England, we did just have a pretty significant storm. So areas, especially of northern New England, may have a lot of downed trees and power outages. And so definitely check for road closures, as this has been a pretty large storm. Not to be a downer here, but just definitely make sure that your planned route is not affected by, say, downed trees or especially power lines.
Helpful, Francis. Yes, we weren't necessarily planning on a big snowstorm this time of the year, but lo and behold, we do live in New England. So yeah, lots of downed trees and a lot of cleanup between now and then. So good reminder. I just have to share this comment because I'm quite envious of this individual. Lisa's sharing that I'm a flight attendant flying a group to view totality. We're going to Little Rock, but they changed to Muncie, Indiana. My hope is that they'll choose Burlington or Caribou. Thanks, Francis, for all the info. I just kind of want to imagine that for a second. So if they're gonna fly a group, I mean, there might be some planes in the sky during totality as well. If you're flying over, what the heck would that look like? And I guess Francis and Shawn, I mean, what can you imagine? I mean, Francis, are you going to be above the cloud cover, even if there are, some those frontal systems you mentioned? I mean, you'd be above the clouds there, right? So perhaps you can see totality.
We're hoping so. Again, we'll be right on the edge of totality, but I hope to see that large shadow maybe imposing over in the northwest sky. That would be really cool to see.
Shawn, have you heard of others in planes during eclipses?
Yes, definitely. In fact, there's a few times where folks who are really serious eclipse chasers chartered planes. I'm definitely not in that group. You can't afford to do so, but I do know of some folks who have done that. Yeah, because it is visible from planes, kind of like the high altitude balloon thing. The whole piece with that is getting above those clouds. And we've even had pictures taken from the International Space Station looking down, and you can see the dark shadow disk. But yeah, if you're up in a plane, you'd be able to see it. And one of the advantages to that, some folks have said, is that you can fly along the path of totality and actually extend totality a bit. Yeah, I even heard a friend of mine was telling me about in the 70s, there was a Concorde trip back when they used to fly the Concordes that flew along the path, and it extended totality for quite some time. So it gave them a longer totality than they would have experienced from the ground.
Yeah, maybe not flying at quite 2,000 miles per hour, like you mentioned, but not too far away in a Concorde. That's amazing. Well, this is great. I want a special shout out to a friend and teacher, Amy, who's reaching out from Maple Street School in Hopkinton, New Hampshire. Thanking both Francis and Shawn for a great presentation. She's going to be sharing this with her sixth graders, and also they're going to be viewing the eclipse with their eclipse classes. She's curious. Francis might put you on the spot first, but what's a key piece of info you'd love young people to know about the eclipse? I know you've been connecting a lot with schools lately. What's one of those key things that you've been emphasizing with that audience?
Sure, yeah. So really safety. I've been getting a lot of questions as to, why people are emphasizing safety so much with this eclipse. So one student actually asked me, "But you guys really think our eyes are going to immediately burn out?" I said, not necessarily, but it's not normal to look towards the sun on any given day. So really, just having those eclipse glasses ready, um, and also just really taking it in. Getting off your phone for a couple of minutes as the totality is moving overhead. That's really like a once in a lifetime potentially opportunity for you. So that's really been my main message, just to really be safe with it, but then also when it is happening, just fully take it in and just be in the moment.
Absolutely. And Shawn, I'm sure you've been connecting with young folks too. What have you been emphasizing, if not just safety?
Yeah, again, primarily safety, and also the other thing is that we really do want them to see it, but to do so safely, and yeah, that this is a very special event, and also that just to observe and see what they see, sort of experience all the different parts of it, not just the totality, but just the color of the sky, the way shadows behave, the temperature. There's so many things you can observe during an eclipse, and there's a lot of science that we get from it, from discovering helium in the 1860s to proving Einstein's theory of relativity. Eclipses are really important for science overall. So I hope they, hoping that maybe viewing that will inspire them to want to go into sciences.
Awesome. Yeah, and for learners both young and older, and for those who really want to contribute to the science, much the way that Shawn and Francis and his colleagues will be doing. There are some great citizen science tools, some community science opportunities to participate out there. On my phone, maybe you can see it, maybe you can't, but NASA Globe Observer app is one that has a special app. It teaches you how to do everything. Basically, you get to take pictures of clouds and temperature, how it changes over time before, during, and after the eclipse event. It's not something you can still participate in, but also enjoy the totality of the event during that time and contribute to lots of science happening on the ground, and others, NASA Soundscapes, and some other great tools that are out there. Go to NASA. They have a great page, a list of different ways you can contribute as well. Some other questions. There are lots of questions here. One from Brian out there asking about, he was asking about schools sending up balloons, but I know, Shawn, you had mentioned also the ballooning project. Maybe you can speak a little bit to that, or Francis, if you know anything about the ballooning project that's going on relative to this eclipse event.
Yeah, the one at Maine, I know that there's a high altitude ballooning group that does a variety of different, atmospheric and other types of science. They participated in the last couple eclipses, the one in 2017 and also the annular eclipse that took place last October, by sending up high altitude balloons to image it and take readings. So they're going to be doing that. They were based on weather, they were initially thinking they might have to drive, but now it looks like they are hoping to launch here in Maine, probably just up the road from us in Jackman. But as I understand it, there's actually two or three other additional teams as well that are going to be deployed in the US to do that, because the project is a sort of like Kate. It's not quite as, they don't have like 35 of them or anything like that, but I think there's 3 or 4 teams that are going to be around the US, as I understand it, doing some of the high altitude ballooning from different universities.
Excellent. And relative to that, Francis, I mean, any from a meteorological perspective as well on the summit, I mean, what do you think you might be observing on the day of during your normal observations on the mountain?
Sure things. We may see a sharp and quick decrease in temperatures. I know in some instances, some areas see decreases of 10 degrees or more. We may also see any cloud cover that's around us temporarily start to sort of break apart, right? So we get those fair weather cumulus clouds in spring and summer months. So if we have any of those develop around the terrain up here, those might start to collapse without the daytime heating, of course, being blocked by the eclipse. So yeah, we're looking out for a few things. I'm not sure if winds will generally be affected up here. We're really above the boundary layer, what's called. So that's directly affected by the sun's heating. And so winds may be fairly consistent, but I'm very excited to take observations during the time of the eclipse. That'll be a really cool experience for me as an observer.
Absolutely. And Sean, I know the question was asked, maybe if you can briefly mention the 5 locations you viewed the your eclipse experiences from, but also I'm curious if from a wildlife perspective, if you've had any interesting observations during any of those viewings in the past.
Sure. 99, I was in the Black Sea, and I did see dolphins poking their head out of the water to observe that eclipse. That was pretty cool. 2006 was in Libya. 2017, of course, we were out in the west in Idaho, and then was in Australia last year. And the first one was in 79. That was in Canada, and that was when I was only about 9 years old. So that was the first one. And it was just by chance I was there for that one because my parents were visiting some friends up there, and the eclipse was by chance. Definitely something that got me interested. That, along with a grandfather who showed me the night sky when I was a young boy, kind of got me interested and started. But yeah, birds and animals do tend to pay attention. Crickets, if it's that time of year, they'll start singing. Yeah, they do tend to quiet down. There's even been some really interesting studies around that too.
Oh, fascinating. Yeah, I'm curious myself what that will be like. Dolphins, though, man, that's really exciting.
Yep.
And Francis, I'm not sure, excuse me if you did already kind of reference temperature a little bit, but maybe just one more question for each of you, not to keep everyone too late. But just generally speaking, what were some of the kind of temperature ranges you were kind of seeing region by region, just in terms of thinking about the types of clothing people might be considering and those sorts of things, viewing across the path?
Yeah, sure. That's a really good question. So in New England, under clear skies, we're expecting generally above average temperatures, especially after this last snowstorm we just are getting over right now. So thinking mostly temperatures in the 40s and 50s, and then warmer as you head generally south and west. Currently across the Ohio River Valley, like I talked about, anywhere from 70s in the more southern parts of that area to closer to the 50s and 60s as you go further north than in Texas. It will depend on the extent of cloud cover, but on average temperatures this time of year between the 70 and 80-degree mark or so in that particular area. So,
well, it may not be 70 or 80 up here, but we'll take it over snow and the 30s like today. So that's pretty good.
I'll certainly be
colder where you are,
be wearing my
Francis.
puffy regardless, I think, up here on the summit at least. So
Oh, that's good. If you're up there, that's definitely good clothing. And then yeah, just one last question, Sean. There have been a few different questions, including some of the other things that NASA is up to, and an intriguing question from Christopher about whether the International Space Station or other NASA assets, like maybe the Hubble telescope or some other pieces in space that might be observing portions of the eclipse, if you know.
Sure. So ISS typically does take a look, and they'll see the shadow on Earth, which is pretty cool to see from above. The Hubble telescope or Webb, they can't look at the sun. Doing so would damage things, so they won't be doing any of that. NASA does have some planes that will be flying, carrying instrumentation on board as well for the eclipse too. So there are a number of different NASA projects involved in both the citizen science, but then also some official, just small teams of scientists who are doing some of those experiments as well. But they do have some aircraft that will be flying in the path as well to try to capture some data. So, but yeah, it'll basically be, mostly ground-based things for that.
Yeah, for a change, it's the place to be, I guess, instead of being up in space to be space, huh?
Yeah, I mean, and even we've had telescopes in space and they have what they call a coronagraph, which blocks out a portion of things, but not enough to really see the full corona. You end up having an area that's missing. It's really only from the ground that we get these total solar eclipses that allow us to see that atmosphere of the sun, the corona, right up to the edge. And that's why it's a really important event for scientists.
Well, fascinating. Well, Shawn, I can't thank you enough. Francis, thank you. I know, again, both of you are very busy individuals right now in particular. So I'm just so appreciative. And I know there are lots of fantastic comments, folks sharing their appreciation as well. Apologies for all the wonderful questions we were not able to get to tonight. Francis was just sharing contact information there. If you'd like to get in touch, education@mountwashington.org. Happy to pass along questions to Shawn as his valuable time allows here as well, but we'll certainly try and get to as many questions as possible if you'd like to follow up with us. If you enjoyed tonight's program and enjoyed the free nature of this program as well, certainly we would welcome your support for future programs like this over at mountwashington.org. You can click the donate button at the homepage to support more programs like these. If you had thoughts for tonight's program, suggestions for future topics, please take some time to fill out the Google Form survey that'll follow the program here and also in a thank you email after the fact. And then finally, don't forget to join us for an upcoming program. We just announced another one that'll be upcoming in June, Tuesday, June 18th. Speaking of NASA, we'll have NASA Earth scientist Brian Campbell, who will be joining us to tell us all about the Ice Cloud and Land Elevation Satellite and its mission to measure our changing Earth. So don't forget to register for that program, or you can watch any of the other Science of the Mountain programs you may have missed over at mountwashington.org. Other than that, have a great night, everyone. Thanks again, Francis. Thanks again, Shawn. Everyone have a safe and enjoyable viewing of the eclipse. What a wonderful time. Hopefully you all have out there, and have a great night. Take care.
Thank you. Take care.
Bye, Shawn. Bye, Francis.